Here's our input form. Has 4 fields: a username, an email field, a personal website URL field, and a phone number field. This is the HTML that generates that input form. On line 7, you'll notice that the action associated with this form is to call the login validation.php file and pass the data via the post method. On line 18, I include the login validation.php file. How are we going to validate this data? We've written a class called validator, and the class will validate 4 different types of input. On line 2 through 5, I've defined constants, application constants, for the 4 types of input that this class can validate: alphanumeric, email, URL, and phone numbers. Within the class on line 9, I've created an associative array named types that stores the value of the types of data that the class can validate. On line 10, I have a variable error that will store any error messages generated during the validation process. An empty constructor, we have nothing to initialize during the construct call, so we built the function but leave it empty. On line 17, a private function check type that takes a single argument, the type, that will validate that the user is passing a type that this class can validate. On line 19, I'm using the array search function. This is a built-in PHP array function that requires 2 arguments: the value to be searched for and the array within which to search. If the type argument that's passed into this function matches one of the types in the associative array, then we return true. Otherwise, we return false, and we set the error variable to not a valid type. Then we provide an interface function for the user, a public function getError, that returns any error messages. On line 35 is our main interface function for validating input. Public function validate takes 2 arguments, the input and the type of the input. On line 37, we first check to ensure that the type that's being passed in is a valid type for validation by this class. If so, we use a switch statement on that type to call the appropriate validate function here within the class. So if the type is an alphanumeric, we call the appropriate function, email, appropriate function, and so on. If there is no match in the switch clause, we return false. If it's not a valid type and fails the if clause on line 37, we also return false. Now let's look at one of the validate functions. We have a private function validate email that takes a single argument, the input. We pass that argument input into the filter var function using the sanitize directive filter sanitize email. This will return a value that is stripped of any special characters. On line 71, we call the filter var function passing the email variable containing the sanitized input, and we're asking filter var to validate that the input is actually in the format of an email address. If so, we return the email address. If not, we set the class error variable with a message and we return false. It's the same structure for the other validate type functions. All of the validate functions are private so that as the class designer, we can manage the interface with the user. The user's interface is a single call to the validate function, passing the input and the type. We, within our class, have designed the mechanism for validating that data and type that's passed in by the user. This also makes the design very flexible in that we can add data types without changing the interface of the class. Again, a very important point when designing a class is that once the interface is public and is being used by other developers, we cannot change it without risking breaking applications. We can always augment the functionality, but we cannot change the functionality that was previously published. So this design for the validator class makes the class very flexible and extensible in the future. So again, validate URL follows the same structure. We call filter var passing the input and the sanitize directive filter sanitize URL. That returns a value stripped of special characters. Then on line 85, we validate that URL, again with a call to filter var. If filter var fails to validate the URL, it will return a false. Otherwise, our URL is returned to the caller. On line 96, we validate the phone number. Notice on line 98, we're using a regular expression to do the validation. There is no built-in sanitize directive for phone numbers in PHP. There are sanitize directives for integers, for floats, but not for a phone number. So we have to create a regular expression and call the regular expression match function pregmatch, passing the regular expression and the input value. If there is a match, we'll return the input value because it is a valid phone number. Otherwise, we're going to set the class error variable and return false. Line 109 is a private function to validate alpha numeric or string values. The input value is passed to filter var with a sanitize directive filter sanitize string. That's either going to return a clean string or false, and we directly return that value on line 115 to the caller. Line 119 is a helper function so that a user of this class can call getValidTypes and know what types this class can validate. So there's our class. Let's go see how we can use it in our login validation code. So we're going to require the class. I've set my debug for my code scaffolding to 1. Then I create on line 4 a new validator class, and I store that in a variable called validator. On line 7, I start testing the input values that are passed to me by the post method. The first thing I want to do on line 7 is test to ensure that the post has the value for the associated input field. If it does, on line 9, I trim, that is, removing the empty spaces from either end of the input, in this case username, and I assign that value to the variable username. On line 14, I call the validator class's validate function. That function, you'll recall, takes the input value and the type of the input. And so I pass the username, variable, and alpha. Now, where did alpha come from? Well, recall that we have defined application constants. These are global constant values, so that anywhere the PHP preprocessor sees alpha, it will replace that with a 1. Anywhere it sees email, it will replace it with a 2, phone, a 4, so on. So these are constant values. They cannot be changed during the execution of the code. So we provide these to help our user. On line 14, we're calling the validate method of our validator class object, and the return value from that is either going to be a clean sanitized string or the value false. On line 15, I test that. If anything other than false has been assigned to the username variable, then 15 will fail, and the code will drop to line 20. If validating the string value contained in the input for username fails, then on line 17, we echo that there was an error in the input, and then we ask our class validator to give us that error by calling the getError function. we echo all of that out to the user and terminate the execution of this code. Then we repeat this pattern again for the email. So you see that in the design of our class, we've created a very simple interface for the user to validate inputs. The only functions within the class that the user must be familiar with are the validate function and the getError function. We manage the complexity within the class by managing which validate function to call based on the input type that is passed to the validate function. Again, we repeat this pattern for the email, we repeat the pattern for the URL field, and we repeat the pattern for the phone field. Let's try this out in our browser. We'll put a username. We will give it a bad email account and see if our validator will trap it. And our validator did what it was supposed to do. It checked the username, and the username was clean, and the validator reported that. So in the output, we see some debug information in the first 3 lines. Then the error message that a bad email was passed in during the validation process of the form data. The application developer then would react to the error message by reposting the form with a message to the user to correct the error. So why is this important? Again, security. Even if on the client side using the HTML5 type validators, whether there's JavaScript validators, we on the server side must validate input to protect the server, to protect the database, to protect our application. By using a comprehensive solution like building your own class that provides an easy-to-use validation interface, we can ensure that our application is protected from the most common types of attacks against websites. Once again, it's your turn. In this exercise, we'd like you to enhance the movie class that was created in exercise 9. Specifically, we want to include user input validation and cleansing from the data provided by the user from the form. There may be a benefit in creating a reusable validation class to validate this input. Test the validation by trying to enter the input shown here on the screen. If you're properly validating the input, then your code should prevent this injection attack.